Okay. Is anybody else as tired as I am? Start to wear out a little bit? I think that we're making very good progress. There are a total of 15, I think 15 lectures in 5, right? Yeah. So we're already through almost about 1/3, so that's good. So let's just go ahead and continue through the lectures. Look at if we do. I think we did 5-4 already. Maybe we better look at 5-4 just to be sure. Lecture 5-2. Okay. Yeah, I think this is hard to see if these lights on. I think it's easier to see the screen if these are up, but those are okay. Oh, 5-3, okay, that's good. Okay, so back up just a second. Is anybody looking farther ahead in notes? Yeah. In these lectures? Let's pause right here for a minute. One of the things MATLAB has, one of the many nice features, obviously it's got a lot of good features. When you're doing something in MATLAB, you create what MATLAB calls a workspace. Okay? And the workspace has in it all of the variables that you've used so far with the routers. So to see what's in the workspace, you can put in this command. Whose. Okay? Who is? Whose. And whose asks MATLAB to tell you everything that's in the workspace that we printed out. At any time, if you realize that you need to go somewhere, maybe you want to save it, you can save the workspace. And everything will be saved. And we'll have to look at the format of this command. Off the top of my head, I forget exactly what it looks like. But you can put in a file name. And you can probably put in the location too. I don't remember which subdirectory. But maybe it will only save it in the current subdirectory. If you want to move it, you have to move it later. But you can save the file name. And then you can always load it again. Okay, so maybe you're working on something and you've got a lot of information already stored. So save is a way to save it. So I'm mentioning that because this difference actually is a little bit blurry even. Command line mode is when you're doing interactive, like we showed earlier. You type in commands and they happen immediately. But even that can be saved with this save command. Okay? Or you can write programs like you do in C++. And you can save the program and run the program later. So at the time you start, if you know that you want to save it, probably it's a good idea to do program. But even if you don't know at the time you're starting, you're going to save it, you can always do this save and come back to it later. Okay? There needs to be a question about that. And along these lines, another useful command to know is clear. Clear will just wipe out everything that's in the workspace. It will go to 0. So if you do clear and then a whose, you won't get anything. Whose will not give you any answer because there isn't anything left in the workspace. Yeah. So let's put something in. Let's say why don't you do this? X is equal to 1 to 100 by 2. he would have the previous command and he could just change the brackets and he wouldn't have to type anything else. Okay? Should have given, should have had a lot more. Try, maybe I have these back, maybe I have the second two back. Let's try 1, 2, and 100. Yeah. Now hit the up arrow key. Hit the up arrow key. Up arrow. There, see? Brings back the last command. If you hit it again, it would bring up that command. If you hit it again, it brings up that command. You can also search. Okay? That's really nice. Say you're working for an hour and you put in hundreds of commands. And all of a sudden you remember something you did 30 minutes ago. And you think you'd like to call that command back up. You can't remember, it could be lots of commands up. So if you do the up arrow key, you have to keep going and look at every line. But let's say you remember that started off with x equals. So you can start typing x equals, then hit the up arrow key. And it will search for anything that begins with x equals. That's the next one we'll show you. We'll skip all the others. Okay? I think you should be more excited about what I'm telling you right now. You don't look excited about it. So does everybody understand what I'm saying about these commands? Because it's really convenient. If you think about all the programs that you run, where you have to keep typing in, you make a little mistake, you have to type the whole command over and so forth, MATLAB remembers everything you type in a whole session. And you can go back and go get any command you want that you already used. So that's also useful. Remember, the whole idea of doing the program in the first place is because you want to use the commands over and over again. So in MATLAB, you can actually do something like running a program just using the up arrow key. You could type in 10 commands in a row, and then you want to execute the same 10 commands. You can do the up arrow key to the 10th one, run it, do it again, run the next one. So it's like having your own built-in program with that up arrow key. That's really handy. Right. Well, or do the search. Yeah. Okay, like for instance, I could do this. Did it work for that time? Okay, so I had the format wrong. I had the syntax wrong. So the counter is in the middle, and the first value, last value, and counter. When I wrote it earlier, I had them backwards. I had first value, last value, and the counter on the middle. So this is correct. And it'll default counter to 1. So you can do this command with just two things, 1 and 10. They'll give you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You only have to put the 1 in the middle if you want something else. So now we have A in there is 90 numbers. So you did clear. Okay, did you do lose? You clear it and it is clear. Right? So let's use the up arrow key and put it in again. One more. Go up, hit the up arrow again. There. Hit the return. Yeah, just return. Oh, okay. I just want to get something back into the workspace. See, you tried to clear so the workspace is empty. So I just want something in the workspace, for example. So just hit return. Just hit the return key. Enter. Okay, so now we have A in the workspace. Let's do B equals sign A. B equals sign A. Do that one. Put semicolon. Okay, well, sorry, I was going to say put the semicolon. All right, so just did 100 signs. So again, comparing that to C++, you would need to do loop, where it calculates the sign one at a time for every element of X. Here, not only will it do them all at once, you don't even have to tell it how many there are. It just goes and gets the vector, in this case A. And however big it is, it calculates the sign for every piece of it. Now do a whos. So whos will show us everything in the workspace. There's A, it's 1 by 101, that's how big it is, 200 bytes, double precision. There's B, B 1 by 101. See, so this shows us everything you've currently got on workspace. Now do clear. Okay, now do root. Now there's nothing. See? Okay? So if you were working for a long time, you might have a lot of variables that you took a lot of time to create, and you don't want to lose them, maybe. Right? Maybe you want to run them again later. So then you want to use save. You can always see what you have in the workspace by doing boost. Okay. What else was there? Oh yeah, I'm just going to give one more example about that up arrow. So you might have a line where you do something like this. X equals 1, Y equals 2, Z equals 3. And then you could have a whole lot of commands. Lots of calculations using X, Y, and Z. Then you might decide, I'd like to do these calculations over again, but actually X should have been 2. So you could then type in, because this line started with X, you could type in X equals, hit the up arrow key. It'll search backwards to the first command it finds that began with X equals. So if it goes up here, it'll show you this line again. Then you could just change that number to a 2 and hit return. Now you have those new values in there. Then you could up arrow key to this one, to the next one, to the next one, and go through all those calculations. Okay. All right. Let's go ahead back to the presentation. Yeah, so common commands do calculations. Here's an assignment statement for one variable, a one-line array, a matrix. We already did all these. Yeah, I don't think there's much to say. Here's that command for filling a matrix quickly. Actually, he doesn't show brackets on there. Let's go back to the second exercise. This element of 1, yeah, so you can call out one piece of a vector and put it into 1. This will combine vectors into a single matrix. Let's say that you wanted to make an identity matrix, for instance. You could, well, that's actually a little bit more logic. Never mind that. The identity matrix is already stored. Okay. So here's who tells you the variable. This just tells you the names that you're currently using. I gave you this command who's. The S here means size. You can type this without the S. Who. So who tells you just the name. Whose gives you the name, the size, how much storage it's taking, what class it's in. Sorry. What'd you say? What kind of variable it is. Okay, so double is precision, and it's an array variable. This one is a 1 by 5 vector. Now see, this is the interesting thing about MATLAB. Even the 1 by 1s, it considers that to be an array. It's 1 by 1. Everything is an array. So the grand total, this is using 18 elements. There's 18 elements in there if you added all those variables. Okay. Clear. This clears just little a, so you don't have to clear the whole workspace. You can just clear part of it if you want. Why would you want to? Is that what you said there? Yeah, you could say who or whose. It's up to you. So now you see everything that's stored. But any variable you're using, like he had that example there, so maybe you just do who. tells you all the names you're trying to use. Let's say you're using variables that have these names. Okay? And you know, you look at that list and you say, I want to get rid of time. Just as an example. So you could do clear time. You can put more than one name in this list. So if you want to declare time and day, you do this. Okay? Then they're gone. If you did who, now the answer would be little a, little x, little y. Okay. Clearing all or part of the workspace is not a bad idea before you're going to do input. That's when people do it a lot. Okay, that's coming up in one of the other lectures. We'll start seeing how you read data in our class. Because MATLAB has a much easier set of commands for reading data, but because it's so easy, it might mean that you end up reading stuff in the way you didn't intend. So it's a nice idea to make sure you clear at least the name that you're planning to read. In theory, let's say you had x as 10 by 100. So it's going to hold 1,000 numbers. Then somewhere you read a file that has 1,000 numbers that go into x. Probably you did it right. But maybe just to be sure, it's a good idea to wipe x out because you plan to read the numbers in anyway. And then read x. And MATLAB will figure out what size it should be. So you don't even have to tell what size it is. Okay. Yeah, you can do, this is a command, I don't know if you saw that one, CLC. This is no big deal, but CLC clears the screen and puts you back up at the top of the screen. So if you think your screen is getting too much junk, you can do that. I don't think I've ever used that command. Because you can also just scroll using the arrow key. Just scroll down a little. Alright, so here's some obvious ones. Square root, power. That's the exponent sign, right? So MATLAB lets you use that. I don't think C++ lets you do it. So in MATLAB, this means square. And this can be an expression. So you could also do something like this if you want. You could have y is equal to x to the sine of z times exponent 4 times t. That's fine. MATLAB will evaluate the thing on the right side. So this is equal to writing y is equal to x to the power sine of z e to the 4t. That's fine with MATLAB, no problem. Okay? If you put in, let's say that you call this command and you had t as a time vector from 1 to 1,000, this will calculate y into 1 to 1,000. 1 for every different value of t. No problem. Alright, so you've got, back for a minute, sine and cosine. You've got the sine and cosine functions. Semicolon prevents the printing. Right, so that's sort of the opposite of C++. Square root acts on each element individually. So if you put in 3 values in a vector, the square root will take 3 values. Most of the commands that act on a matrix or a vector do element by element. Most of them. But exponent is a different one. So we already talked about exponent this morning. Well, matrix exponential. That one is not element by element, but most of them are. So the sine of a matrix A, if this is 3 by 2, that's equal to a matrix of the sine of A11, sine of A21, sine of A31, and so on. So it's 6 sines. Right? If this is 3 by 2, that's 6. The sine of that, the matrix, is also 3 by 2, and it's 6 different sines calculated one at a time. Most functions, like square root, sine, etc., if you put a matrix in, you'll get a matrix out that is the same size, and it's the function operating one at a time on each piece of the original array. Most of it. By the way, back up just a second. See, the set of commands that are these so-called elementary math functions, the kind that you probably have a button for on your calculator, they're contained in a grouping called EL for elementary function. So if you just want to see those kind, you can do L1. Yeah, the semicolon prevents the echo. If you don't put the semicolon on there, it prevents the answer. One of the nice things about MATLAB, some of you have asked me questions about programs that are stuck in C++, and you know that my advice usually is to insert a lot of break commands. I think you should see what the output is at the end of every line when you're going through the program the first time. Make sure it's doing what you think it's doing, because it is easy to make errors in the way that you input them or to misinterpret what it's going to do. So it's nice, at least the first time through, to double check every single line. In C++, to get output, you have to put in a cout command. In MATLAB, everything automatically gives you output unless you stop it by putting in a semicolon. So the default in MATLAB is you will see the result of every single line as you go through. I think that's nice. Okay? And if you just want to see the value of a variable in MATLAB, you could just put in that command. You could just put x. You don't even have to put x equals. If you put in this command, MATLAB will answer with x equals, and it will tell you what x is. Whatever it is, you'll see it. Okay. All right. Any questions about that? Do you have exercise 5.3? Yeah, that was lecture 5.3. So if you want, you can look at that exercise, see what it asks, and then let's see if you think you're ready for it. Don't have it yet? Yeah, it wouldn't be a problem. So it would be an exercise. Yeah, we got to get that CD from Mrs. Haas. Somebody's got to go over there and get that. Okay. Who wants to volunteer to go today? Let's go get the CD from Mrs. Haas. Okay, let's look at 5.4. So this is not a normal function. This is just something convenient for you. If you have two columns of numbers, or two rows of numbers, and what you need to do is multiply each pair of them together, but not add them together like you do in a matrix multiplication. This would work, obviously, it would give a 2 by 2. And that won't work. Actually, I have to say, putting these arrows on and then showing where it goes, this is nice power. Whoever put this together, this is easy to watch. Yeah. Okay. Exercise 5.4. Let's look at okay, so it looks like you don't have 5.5 or any of the others, but you have some different. Let's try doing this and see what I got. Okay, so in files are something like C++ programs. Okay. Yeah, let's go back for a second. Two nice things about the in files: you can create them in any text editor. All right. So, for instance, if you want to go into Microsoft Word, you can write your MATLAB program in Word if you want, and then just cut and paste the commands back into MATLAB. Okay, so that's nice. MATLAB also has its own built-in text editor. Another nice feature about M files, which you'll see, is if you think about C++, at the top of every C++ program, you've got to put in all that initialization stuff, right? Tell which libraries to import and all that kind of junk. MATLAB, you don't have to do any of that. The very first command in an M file, MATLAB, would be x equals 2. That would be the very first command. So, I think that's one reason why, if you notice, when we were doing the C++, I have a hard time remembering those first 3 or 4 lines that are in every C++ program, because I usually use MATLAB. And in MATLAB, you never have to do that. You just start writing the commands that you want. Okay. You do have to tell MATLAB where to look for your M files. So remember, you've got the current directory. You can browse to a new directory, like I said. You can select a new directory. So I said this earlier, this is another feature that's better than C++. You can store your files wherever you want. They don't have to be in the same directory. C++, they do have to be in the same directory. You just have to tell it where to look. As long as it knows where to look, you can put it wherever you want. Okay, so if you click on this file, you get a menu, and one of the choices is New In File. You click on New In File, it opens up its own text editor. And now you can put the in file in, the new in file in the text editor. Okay. So look at this this in file. This is the in file editor. So I'll repeat something I said just a minute ago. There's no junk at the top of it. The very first command is a useful MATLAB command. So is the second, third, fourth. It puts this number system over here that's just a convenience for you. That's part of the debug. Because when you go to debug, if there's an error, it'll tell you which line it's in. So in an M file, unlike in the command window, every time you hit enter, it executes the thing you just typed. Right? If I type x equals 2, and then I hit enter to go to the next line, it writes x equals 2. In the in file, it's more like an editor. If you hit the return key, it doesn't execute. It just goes to the next line and you type the next one. So you could put in all of the lines of an in file at once without any of them executing. That's why it numbers them, because then when you go back to debug, the error may be way up high. Now, if you're doing it in a command window, if you put an error in, if you type x equals 2, let's say, and this is a bad command, as soon as you hit the return key, you'll get the error message right away. So there's no question where the error was. But if you put in 10 commands in a row and it's not executing them, then when we finally go to execute, if the error is in line number 3, it has to tell you where it is. Okay. All right, so you then save the in file. Okay, and you've given it a name. Okay, you've given it this, in this case, he called it x and y.m. The file extension should be .m. That's the file type always, but the name is whatever you want. If that's in the subdirectory that you have in the current place that you're telling MATLAB to look, you can just type that name anytime you want, and it'll run that in one. So again, compared to C++, you have to put in the function declaration statement at the top. Then you have to put in the function definition down below. If you do those two things, you can call that function anywhere you want in the C++ program. In MATLAB, all you have to do is save a file that has the .end extension, and it becomes a function that you can use anytime you want. You never have to declare it. You never have to put the definition. So it's really a lot easier to do than C++. Okay? Any question about that? No header files needed. Arrays do not have to be dimensioned. Variables do not have to be given a type. Can you go back to the last one? Back further. This line. Running the program doesn't create lots of other files. Right? So compared to C++, especially these first three, it saves you a lot of work, I think. A lot of annoying work. Because creating all those header files, putting in the dimensions of the arrays, all that stuff in C++ doesn't really have anything to do with the calculation. That's just bookkeeping to set it up. MATLAB does all that automatically. Okay. So to change an in file, you can just go in and edit the last 2 lines. So you change them over to transpose. Then you have to save the file. So then that's what comes out when you type in the command. So now you're seeing the transpose. Now I'll tell you something that has driven me nuts on more than one occasion. That maybe this is me being stupid, but if you can benefit from me being stupid, I hope you do. You go into the edit window of your in file. You make the change that you intend to change. You go back over to the command window and you type in the command, and you get the same thing that you got before. And you're like, oh. So you go in and you erase it and you type it in again, and you go over and you hit the command and you get the same thing again. What am I doing wrong? Yeah, I'm doing one thing wrong. I'm missing one thing. Save. Okay, this is an edit window, just like any other edit program, like Word or Notepad or Text or Notepad or WordPad or any of them. Until you hit save, the new version is not written onto the drive. So you can change everything you want here, but it doesn't show up in MATLAB until you hit save. And that's the thing I sometimes forget. I'll open this window, I'll be really excited, oh, I want to change something in my file. I type in the changes, then I go to run it in MATLAB. It didn't change. What happened? You have to hit save. Okay. Alright, so he's suggesting examples. You probably don't have these, right? They're on that CD. So there are example in files on that CD. You can take all those in files, put them in your directory. Then you can run them whenever you want just by typing their names. So it looks like he's got a lot of them on there. So those are all in files. You just type any of those names. They're like separate commands. They do whatever it is that's inside of them. And you can also edit any of them you want. They're not write protected. So if you want to change any of those examples, you just open them up in the editor, change them, and then you do what? Save, and then you can run it, and you have your new version of that. Okay. Anybody have any questions about this structure? I mean, I think this is really beautiful compared to C++. And also Fortran. You know, Fortran was the major language of scientific calculation for probably 20 or 30 years. Everybody who did scientific calculation was Fortran. Fortran requires the same kind of setup commands at the top of the main program, and every time you have a function or subroutine as C++. It's that same logic. Now MATLAB comes along, and it's so easy by comparison. If you want to put everything in an int file, you only have to type the stuff that you really want to calculate. You don't have to dimension arrays. You don't have to declare what they are. It's great. You don't have to pass variables. That whole pass by reference, pass by void function, pass by reference stuff. Yeah, if you have an error in the int file, you call. Anytime you type the int file, it just executes all those commands that are inside the file. So if there's any error in there, when you call the int file, it will be in the command window. The error will appear in the command window. So you'll see it because it'll execute in real time. Yeah. In C++, you would put C out any place you want to check an intermediate result to see if it's doing the right thing. In MATLAB, you just leave the semicolon on. So if your int file, if the commands in your int file don't have semicolons, when you call your int file, when you type X and Y, the output of every one of those commands will appear in the command window if you don't have semicolons on the end. Okay? Remember, the default is to print whatever the result of the command is. If I write X equals 2, the output of this command is MATLAB writes X equals 2. That appears on the screen. That's the default. If I want to stop this from appearing, I have to add that. Then nothing shows up. So from a debug standpoint, if you want to debug a MATLAB program, just leave all of these off. Then you'll see the result of every command automatically. You don't have to put anything else. And if it's in an int file and you call the int file, the same thing is still true. You'll still see the result of every single command. Okay? Now, you can very quickly overwhelm yourself if you're running a big problem with thousands of variables and you don't have these on there. You can hit the return button to start the execution, and your screen just flies by. You know what that looks like. You know, when the screen on your computer is scrolling so fast, you can't even see anything until finally it gets to the end and you see the last little bit. Now, if you want to see the output of all those commands, you have to use the up arrow scroll key, to go back up, way up in the window and see what the output is. So, I think it's a really helpful feature that you can leave that off and see the output of every command. But if it's a big program, it'll mean you have a lot to look at. I think I was going to say one other thing about files, but now I can't think of what it is. So let's talk for a minute about file by reference. In MATLAB, everything that you're doing is in the workspace. Okay? So there's no difference between file transfer by reference, call by reference, right? Like there is in those different functions inside of C++. In MATLAB, the variable name X is X everywhere it appears. There can only be one X in the workspace. Okay? So in MATLAB, it's as if everything that you define is by reference. Okay? In C++, you could put in C++, you could have a function, say void func, and you could pass into it. Well, when you call it, let me call it over here. So over here somewhere, I say y is equal to fun of x. Where I have the actual function laid out, I could give this name a different, I can give this a different name than X, right? I could call it over here gobble. Just making stuff up. Now in the void function, I calculate gobble. At the bottom I write return gobble. Oops, I guess I don't want to void, sorry. Return gobble. The value that this calculated for gobble gets transferred back to the main program in X. So the same value has two different names. Right? And if I change something on gobble in here, I'm changing something in X over here. That's where transferring the values back and forth in C++ gets dangerous. Okay, in X, in MATLAB I mean, this kind of logic, transferring things by name, doesn't exist. If I want X over here, I just put X, because I never have to transfer something by name. If I want X, no matter what part of the subroutine I'm in, no matter what function I'm in MATLAB, no matter which IM file I'm in, if X is part of the workspace, it's the same X everywhere through the program. And if I change it anywhere, it's just the new value of X. So I don't have to worry about transferring something into the main. Right? Remember I gave you this example where I put 3 in here. Then I come over here and I calculate a bunch of stuff, and then I return gobble. And maybe gobble has the value 4. Now in C++, 3 is 4. Right? So I really screwed myself up. You can't do that in MATLAB. You can't screw yourself up like that in MATLAB. 3 is always 3. X is always X. Gobble is always gobble. There's never a situation where two names occupy the same, are supposed to represent the same values. Do you see the difference, the logical difference? Yeah, so this is a lot safer for that kind of thing. Now, I've said all this great stuff about how easy MATLAB is to use. What's the worst kind of error that I said there's always two kinds of error. There's the syntax error where you get a message right away because you type something that it can't do anything with. And the other kind of error is when it executes just fine, but it's not what you intended. Okay, that kind of error is more likely in MATLAB because it's so accommodating, right? Because it's so flexible, because it allows you to do so many things. It's a lot easier to get a program to execute. Therefore, it's a lot easier to get one that's not executing the way you intended for it to execute. So you do need to pay attention to what you're doing line by line. Okay. Yeah, this is that just shows you another way of running an IM file if you want. Okay. Okay, data input from a file. You can compare this methodology with what you have to do in C++, see which one you think is easier. So I'll pause whenever you get a chance, Alex. You create a text file. This says WordPad or Notepad. Actually, it doesn't matter what you use, but it should be a file type TXT. Okay? The values should be separated by spaces. It doesn't matter how much space. So just like in C++, you can use the tab command. So it always jumps to the same column, and you have nice numbers all lined up. I think that's a nice thing. But you don't have to. As long as there's a space in between, that's fine. Make sure you save it in the correct directory. The correct directory is the one that you're telling MATLAB to look into. Okay. To put data in MATLAB is a simple command, load. So first he put in clear, that clears the whole workspace. Then he loaded x and y data.txt. The load command will take that data and put it into a variable, x and y data, because that's what you call it. And it'll make it whatever size it reads. So you don't have to tell it in advance how big it is. Right? Whatever size that data file is, it'll read it. Then you can type a who's, and it shows you it has this. You can type x and y data. The output of that is just to print the values. Okay? Pretty easy. Yeah. It doesn't have that C in just load. Okay, once the data is in, you can apply it to other data. Now here's a couple of useful commands. You saw this in the assignment function with the colon. The colon in the middle of two numbers in MATLAB almost always will enable you to do the whole string. So remember, if I write x equals 1 to 10 like that, the output is x equals 1, 2, 3, 4, 5. It makes a 10 by 1 variable. I'm sorry, 1 by 10. With the values 1, 2, 3. So that colon is really helpful. Okay? If I'm referring to a matrix, let's say that I put in x as, let's say that I have a matrix like xy, and the size is 2 by 7. 7 numbers here, 7 numbers here. If I want to print or refer to either one of the rows or one of the columns, I can do that using the colon command. So xy, let's say xy equals, well, xy is a variable. Let's say z equals xy of 2. Yeah, this is syntax. Can you go back again? Make sure I put the syntax. Yeah. X and y of 2 colon. Yeah, let me back up to a more generic version. If x, y, so we've got x, y is 2 by 7. I can put in a command like, I'll say p is equal to x, y of 2, 4. That's one number. It's the number that's in row 2, column 4. So it's this number right here. Now let's say I want to put in a whole row into another variable. If I say z is equal to xy of 2 and then put the colon, that colon tells it to put in the whole row. So it puts the whole thing in. That's pretty handy. That replaces a for loop in C. Okay. So that's what that last one does. That's what these two commands are. So x data loads the first row, y data loads the second row. So you can pause for a second. So to save the workspace, you can go to the File menu and then use the Save Workspace. There's a button for it in the File menu. To load the workspace, also in the File menu. A workspace is a file that has the extension .mat. So when you're looking for it later, you're looking for .mat files. He says it's not used frequently. I don't agree with that. Actually, I think people use this a lot because it's very convenient. Maybe he doesn't use it frequently. Okay. So he's just showing you how to create a workspace, right? So he had 3 variables in here. X and y data was 2 by 7, x data 1 by 7, y data 1 by 7. There's a total of 28 elements. You click on the File menu, save a new workspace. You can give it any name you want. So he gives it a name down here. I can't read that. Whatever that name is. It has the extension .mat. And back at the command line, he clears the workspace. He types whos, and there's nothing. So he had these 28 numbers stored. He then saved the workspace that put those 28 numbers into that .mat file. Then he typed a clear command that wiped it clean. So then he did whos, nothing comes out. There's nothing in the workspace. Now he's going to load that other workspace back. So you click on File, click on Open, put in the name of the workspace is getting data through an M file, if you want to do that. So he puts in a load command, right, to load up the data. The same statements that he had before in the command window are now in file. No problem. You don't have to pass variables, you don't have to declare anything. The exact same commands that he used in interactive mode in the command window are now stored in the file. Okay. This is how you can, this is like the CN command. The last one was reading from a file, it was like IF stream. This is like CN. Okay? You can do input. And here's a really nice thing again compared to C++. Remember in C++, we usually used a cout command first. And the cout command would say something like, please type your favorite color. Then there would be a cin command that would read the color that you just typed. In MATLAB, you can put input followed by a pair of parentheses with quotation marks, and it'll write that as part of the input command. Okay? The thing that you're reading in, you put on the left-hand side. A equals input, and then you can say what it is you want to type. So when you run this, what will appear is enter a number. So then he enters a number, enter a vector. He enters a vector, enter a string of characters. That's another nice thing about MATLAB, I should say. If you remember in C++, a character variable stores one letter. So when we were trying to compare blue, yellow, orange, we had to look at the first letter, see if the first letter is B. Remember if we had brown was one of the choices, we'd have to look at the second letter. We'd have to look at two different character variables. One for the B, then look at the second one, see if it's L for blue, R for brown. MATLAB character variables can be probably not as long as you want. There's probably some limit, I don't know what it is. But a single variable A could be a whole sentence. A equals, two quotation marks. Right? I love higher level language class. And that would be the character variable A. That whole thing would be stored there. That's right. Yeah. I mean, how good is that too? Again, compared to C++. So in C++, I have to declare at the top of the program, this is a double array, this is a double number, something like that. And that I can just say A is equal to input. And then you're not obligated to put that label in there. It's just such a nice idea, why wouldn't you? So input A. So you get this command, and what appears on the screen is input A, and it waits for you to hit a carriage return. Okay? So now you start typing. You can type 1, 2, 3, 4, semicolon, right? That's the end of the first row. 5, 6, 7, 8. You put in a two-dimensional array. Right? The size is 2 rows, 4 columns. You put in a two-dimensional array 2 by 4 with this one command without ever telling them what you're going to do. It's awesome. Okay. I will say, I think when you do this though, I think you're supposed to put a bracket at the beginning and a bracket at the end. I think. I'm not sure. Also, that character having multiple values in a character string, I think that's also really useful, like I said. You know, C++, if you want to store a word in C++, remember you have to have the same number of variables as the letters in the word. So let's say that we're going to read in a bunch of color names. Blue, okay, 4 letters, brown is 5, orange is 6, yellow is 6. So all of those are a different length, a different number of variables in C++. Blue is 4 variables. Yellow is 6 variables in C++. It's a nuisance to keep track of. In MATLAB, you can have A equals blue, B equals yellow. It doesn't care how long it is. It doesn't matter. Okay. I sound like I'm really promoting that. I realize that. There's a reason why I sound like that. I am promoting it. MATLAB is the program that most serious programmers use most of the time. I really think it's okay to learn C++. The advantage of C++ is because you have to do all those little pieces of the program yourself, it's great when you're learning how to program the first time that you have to do that. And so you really start to understand the logic of how a program is made. Once you understand the logic, you can appreciate how great a program like MATLAB is that does all these things automatically if you don't have to do it. So if you only ever learn MATLAB, maybe you would appreciate it so much. Yeah. Maybe it's something like, I don't know if this is a good example. Let's say that you needed to dig a trench, between two buildings on campus. So I give you a shovel, and you work out there for 2 weeks, hot, sweaty, trying to dig a trench. And then one day I show up with a tractor, nice diesel engine. It's got a nice cab on it, it's air-conditioned, stereo, and you sit in the air-conditioned cab listening to music, and there's just a few controls, and it digs the trench, and you're done in 1 hour. And you don't sweat at all, right? You really appreciate that tractor. If you started with the tractor, instead of doing this for 2 weeks, maybe you wouldn't appreciate the tractor. So C++ is this. MATLAB is the tractor. Okay. Let's look at 5.7. MATLAB has really nice plotting. I think that the MATLAB plotting is ultimately even more powerful than Excel. But some of the plots in Excel are really easy to make kind of cool, beautiful plots, like those pie charts that are three-dimensional where it's tilted a little bit and the pie looks like it's thick. I mean, that's pretty cool. That kind of thing people don't usually do in MATLAB. MATLAB usually is more of a scientific looking plot. But it has really good plotting. It's very, very strong. So a real easy thing to do, back up for just a minute. Oh, that was the first one. I'm sorry. Okay, go ahead. With a single command, you can draw the basic plot. Right? So the format of this is you put in variables, and you can put labels all inside of a single command. That's the plot command. That'll draw a nice picture. It has a default about putting a grid on, which I can't remember if I think it's default on. Maybe it's default off, and you have to ask for it. But there's the grid, so that adds the grid lines. Here's labels you can put in. You can put a title on it. You can put axis labels in. Right, so I think probably the best way for you to play around with these commands would be to, when you're home, right, just fool around. Instead of putting all of these commands in at once, like he's doing here on one line, just put them in one at a time and see what each one adds to the plot and takes away from it. You'll pick it up. You'll figure it out. Okay, so if you can pause this for a minute. All right, so if you remember in Excel, you can put in X and Y data and call a plot, and it makes a nice line. Then if you want to add a second line, you have to put more data in and tell it to put a second line on it. In MATLAB, in the same plot command, you can draw as many lines as you want. Here's the pattern. This is X data, Y data, and then this thing, it looks like a character variable. See, it's inside of quotation marks. And it's got two symbols. The first one is a color, and the second one is a shape of the symbol that will go with the data. So R is red, and O is a circle. So when it draws that line, it's going to use the X and Y data and draw a bunch of little circles using red ink. Okay? Then it plots more data. Another line on the same axis if you want. Because it's in the same command, it will be on the same set of axes. This is plots this X, this Y, B minus. B is blue, and minus is a connected line. Now, if you do the help plot command, you'll see what all of the choices are for colors and what all of the choices are for symbols. There's a lot of them. You could put 100 lines on your plot if you want, with different symbols for each one. It would be very difficult to read a plot that busy, but you can do it if you want. So the next one is going to be connected line, and it's going to be drawn with blue. Right, this puts a title on the plot. You have choices about where you locate the title. But this is going to put it, I think the default is to put it at the top in the center. X label puts a label on the x-axis. Y label puts a label on the y-axis. Grid draws lines in. Axis, I'm not sure what this, I think axis tells what the labels are that you want for the X. Will go from 4 to 12. Y will go from 0 to 50. It sets the scale of the axes, the minimum, the max, the min, the max. Remember how I told you in the old days when you call plot, they would scale the line to whatever your data was, and you could get these labels that were ridiculous. Like instead of 1, 2, 3, 4, it might be 0.756, 1.325. Nobody who's read mine would draw a plot where those are the labels that you put on. You pick the numbers that are nice and round, so this gives you control over them. Okay. So there are the two plots. Now he plotted the same data twice. Right? Once he plotted it with the red circles. So if that was the only thing you put in, you wouldn't see the blue lines. The blue line came from the second command. Okay. Here's the label of the plot. See it's centered and it's above. You can control the font size and the color of that. You can also move it. Here's the x-axis label, here's the y label. He selected the scale from 0 to 50 and also the scale from 4 to 12. Fix the best line, like the best fit. Yeah, we have to, there's a command to do something like least squares fit. There are different commands that will smooth that line out according to how you want it to calculate. This is not calculating a smooth fit. This is taking 1, 2, 3, 4, 5, 6, 7 points. Yeah, you could calculate a function that would look smoother than this blue line. This blue line is just connecting each pair of points with a straight line. But if you think there's really some smooth function that this data represents, the data is only the red circles. These blue lines don't mean anything, right? That's just the way that he decided to draw his plot. But they don't mean anything. Only the data, the red circles are the data. So if you think there's some function that better represents that data, you can calculate that function and plot that function. Okay? What's nice about all of these commands, including the plot command, you can always insert the calculations right into it. So for instance, you could do this set of commands. You could have t equals 1 to, well, let's say 0. 0 to, I'll say, I don't know, 3. Sorry, this is the counter. 0, 0.01 to 3. Okay? How big of a matrix would that be? How big is it? It's 1 by about 300. Right? And you have to be careful with the ends because if both ends are included, it's actually 301. This one I think is 301. Okay, so 1 by 301. The very next command could be plot for my x-axis t and for my y-axis sine of t. And I can stop right there. That will draw a plot of the sine from 0 to 3. Those two commands. What will the plot look like? It'll look like whatever the default is for the plot command. And I think the default is like the blue line here where it just connects every pair of points. If I want to override the appearance of the plot, then I can put in something like R0. Now the plot will look like a bunch of little red dots. Or I can put in blue minus, and it'll look like that blue line. just type it in. Now I've got this plot of the sine. If I want to now add on the same set of axes, let's say I want to add the cosine, I would put comma, t on the x-axis again, cosine of t. Now maybe I use blue minus again, blue plus, blue plus. I don't know what that does, but let's put it. Okay, now I've got two lines. One is the sine, the other is the cosine. Cosine will start at 1 and come down towards 0. Each plot has 300 points. The 300 points for the sine plot are calculated right there, right in the middle of the plot command. They're actually calculated. 300 points for the cosine are calculated right there. Any question about that? Or 301? Maybe it's 301. Well, you have a question. Why is that 301? Well, the first one is 0, and the last one is 3. This one is 0.01, 0.02. So 100 later after this one is 0.99. This is the 100th point. So when I get down to 2.99, that's the 300th. 3.00 is 301. Yeah, input. The counter goes in the middle, and the final value goes here. Yeah, so earlier I wrote one that looked something like that. The output of this is just 1. It'll do the first one, but then it changes by 10, so the next value will be 11, except this says the maximum is 2. So once it gets past 2, it stops. So this would only have one output, not 1. If I made this 20, if I made that 20, this would have 2 outputs. It would be 1 and 11. Okay? If I made this 0, it has 3 outputs. Those 3 outputs are 0, 10, 20. Actually, I'm glad you asked this question because it's important to understand this. So maybe we should have done these examples sooner. Did everybody just follow this? Let's do them all again real quick. So what is the outcome of doing this? It starts at 1, so that's the first one. Then it changes 1 by 10, so it goes to 11. But the maximum it allows is 2. You put that in as the maximum. 11 is higher than 2, so it's not happening. So that's it. That's the only output it is. However, now if I make this 20, the first one is 1. That's fine. It's less than 20. The next one is 11. You add 10 to 1. That's less than 20. The next one would be 21. But 21 is bigger than 20, so we're done. 1 and 11. If I make this 0, the first one is 0. The next one is 10. The next one is 20. The next one would be 30, but 30 is bigger than 20, so we're done. Yeah.
What's the difference between the new maximum in the morning? The first number should be the start and the middle number should be the end.
Yeah, this morning I had the format wrong. I had the end in the middle. That was incorrect. Yeah.
No, I understand the end.
This
No,
is
the end is the middle.
Did I do it wrong now when I had it right earlier? Is that what you're saying?
This morning you said the end is the middle.
In the morning I know that I did it wrong once, and then I fixed it. But was this the doing it wrong, or was this the fixing it? Let's look. Alex, you have your beautiful, you have the MATLAB program running, not the power. Okay, good. Down here, put x equals. Actually, you don't even have to put the x equals, but that's okay. Right, left bracket. 10, colon, 20. Right bracket. Yeah, so this is correct. This is the right colon. Yeah. So it's the start, the delta, and the end. And this, as I said before, I want to repeat it again so that you know, this is optional. If you're happy with 1, that's the default. So if you write 0, 20 like that, that's fine. What you'll get is 0, 1, 2, 3, 4, out to 20. You only put the number in the middle if you don't like a change of 1. Okay? So another thing you can do on the time, for instance. This is going to give you a 1 by 301, and it's going to have the values 0, 0.01, 0.02, down to 3.00. What's a way that I could do that same thing without the counter in the middle? Does the exact same thing. Does the exact same thing. Anybody confused by this? Again, this is the beauty of MATLAB, the fact that you never have to tell it how big these arrays are. It'll figure it out. So this becomes a matrix that's 0, 1, 2, 3, all the way up to 300. Then I divide by 100. Because this is a scalar, it knows that the division means take each piece of this matrix by itself and divide by 100. So the first one stays 0, the next one becomes 1 over 100, the next one is 2 over 100, the last one is 300 over 100, so it gives you exactly the same thing. Okay. Any questions about that? I just think this is cool. I'm sorry, maybe this doesn't, maybe it's cool, I just love this. I think it's so cool that this works like this. That statement and the statement are exactly the same. I'm not sure we can do this experiment if we want, but I think we could actually take this and put it right there. Maybe not the t equals, maybe they have to leave that off. Yeah, I guess maybe it doesn't work because we want to calculate the sign of t, so we need to have something stored as the name t. And I don't think you can store it like this. I don't think that would work in there. But this would definitely work in there. That would give us 301 points in that spot. That would definitely work. But the only trouble is we wouldn't be able to call it here. However, we could, if we're not very efficient, we don't care, we could calculate it again. So this statement would work. Plot 0 to 300 slash 100, comma, that's the x variables, sine of 0 to 300 slash 100. That will work. So inside of the plot command, we're calculating all of the x numbers and we're calculating all the y numbers. Inside of the plot command. It's awesome. Now, even Excel, with all of its slick plotting, expects you to calculate the numbers in advance, then import them into a plot function that plots them. But this, you just stick whatever calculation you want inside of the plot command if you want to do it. Now, from a logic standpoint, maybe you don't like writing the program like that. Maybe you would rather have a separate calculation, get all the numbers, and then plot the numbers. Maybe that makes you feel a little bit less nervous. That's fine. But if you want to do all of it in one command, you can, no problem. It's awesome. Okay, let's go back to this PowerPoint. Okay, so here's some figures. You can label your figures. Okay, figure 1, figure 2. thing is, you've got different figures that you've labeled. So he plotted that first set of data onto one, and the second set of data onto a second one, and he labeled this one figure 1, and he labeled this one figure 2. You don't have to use 1 and 2. I think you can put in any number you want. He used 1 and 2. Subplots. Okay. Let me rest with it first. Okay. Subplot is the number of rows of subplots. The second number is the number of the columns of subplots. I'll say more about exactly what that means in a minute. The third one refers to the location of the next plot. So now it's going to treat this as a subplot using, now let's see, what is this? Oh, figure 1, yeah, I'm sorry, it took me a minute to remember what this is. He plotted two separate pictures, right? By calling them subplots, he creates in one figure, this is one whole figure, 2 separate plots. See the difference? So before there was one set of axes, and it had one plot on it like that. Those are the red circles. Then it had a second plot on it, which was the blue line. And they were on the same set of axes. So that figure had one set of axes. Now he's making one figure, but the figure has 2 separate axes. So maybe that's how you want to compare your data. And so you tell it how many rows of subplots that you want. He said 2. So go back. So this is like a matrix of plots. This is a 2x1 matrix of plots. 2 rows, 1 column. And he called it figure 1. Number location of the next plot. So here's the plot, and it goes into the first one and the second. It's got 2 of them. Let's go back for a second. If you looked at your journal articles, it's quite possible that you saw some of the output of a journal article was done like this. Right? Sometimes when you want to present your results, this is a better way to show something when you put the 2 lines on the same axis. One thing I think he should have done in this example would make it even more obvious. He used the exact same labels on both plots. On a subplot, you don't have to do that. Each one can have its own label. So this one maybe could say something like an original data, and this one maybe could be labeled line fit of the data. Because like we said, the data are these 7 points. What happens in between points, we don't actually have any data for it. But like you said, maybe there's a function that we think fits that data. So this could say data, here it is. And this could say function fit of data. And then it shows that curve line. Yeah, then you have 6 pictures. You could have 3, 2, that would be 6 pictures. And you don't have, this is plotting them first one, second one. So you would have a total of 6 that you need to plot. But you don't have to plot them in order. You could put, it would eventually want you to have 6 pictures. But you could put number 3 in first. Then you could put number 5 in. Sorry, number 5. Then you could put number 2. Then you can put number 1. You don't have to put them in the order that, you don't have to put them in the exact order. Something else you can do, as long as we're talking about having multiple lines on the same picture, MATLAB will create a legend for you. That's handy also. You know what a legend is? A legend is if you have multiple lines on the same plot. Maybe one of them is circles, one is a straight line, maybe one is little triangles. Some other data. Somewhere over here you have a box. and it says, here's the red circle, and next to that it says data. And then you have the triangle. Next to that it says, what's another thing that you might have in the plot? Year, something, data 2, whatever it is. But the point is, you can put right on the plot the description of what each of the lines is. Because when you look at a good science paper or a good textbook, if they show a plot and there's 3 or 4 lines, usually somewhere on there's a legend. It tells you what each line is. You can put that in yourself. Same thing in here. It's got an example. Yeah, that's good. 3D data. This is where I think it's more powerful than Excel. Just when you want to do these really fancy plots. So there's a nice 3-dimensional plot. Now, you can plot it as surface or mesh. Okay, what's the difference? Yeah, what is mesh? This isn't exactly a mesh, but it's closer to a mesh. Mesh is like individual strings or bars or something like that you can see through. So if you have a mesh, you would be able to see the axes or see the labels behind it. It would be see-through, but there would be lines out there. But a surface will appear solid. You can't see through it. That's the idea. So you can choose whether you want a surface or a mesh. So surf, that command called surf, creates a color-coded surface plot. Like this. Okay? And you can put in, now here, this is an example of a legend. So this shows what each value, what the values are that go with the colors. I don't know if you can see that very well. But it says, down at the bottom, I think it says 1, the top says 4. So if you're trying to read the value here, because it's a relatively small 3D plot, it's kind of hard to say exactly what the value is. You can tell what the value is from this color. Okay? This is the same data, back up just a second. Same data plotted as a mesh. Again, it doesn't show up very well on this projector, but now all the data is just these lines you see through it. It doesn't have a solid surface. This has a solid surface. This doesn't have solid surface. That's supposed to be what happens. Do you remember when I talked about how trying to land the airplane on the end of the runway, we talked about 1 sigma, 2 sigma, 3 sigma, and it's 3-dimensional. So if I wanted to plot a shape that represents the probability that I know where the airplane is to something like 0.99997, something like that, it would be, say, 4 sigma, 5 sigma. But there's 1 sigma in the z direction, 1 sigma in the x direction, 1 sigma in the y direction. So that shape ends up being something like a rugby ball, but not even a rugby ball, because a rugby ball is symmetric in 1 dimension. Right? If you look down the long end of a rugby ball, it looks like a circle. So this thing wouldn't even be, it would be an ellipse in that direction, plus it would be stretched out in the long end. Okay? Well, I could plot that. I can plot that on you and have that nice shape. Maybe underneath it, I plot the runway that I'm trying to hit. And that can be a way to visualize it, like I talked about earlier. You know, it's one thing to say, here's your airplane landing, right? A bunch of numbers. But it's another thing to say, here's a picture of the end of the runway, and here's this shape. And this is a 99.999% accurate estimate of where the airplane is going to be. And you can see that the shape is inside the runway, where it's supposed to be. It's a much better way to present the data. Okay. Something like GUI we were talking about earlier. So he's got several 3D plotting examples plot versus a mesh plot. The mesh plot is just the lines. The surface plot fills them in with the colors. There's a rotation tool in the 3D plot. How cool is that? So if you want to look at this 3D thing from another angle, you can rotate the whole plot. Right? Look at it from lots of different angles. Okay. Any questions about plotting? You know, I think I've said this already before a couple of times. I'll say it again. I know that if I were sitting in your seat, I'd be nervous because it seems like they're going so fast. But I just want to remind you that you can always look these things up later. Like I said, I never remember these commands. I always have to look them up, and I've been doing it for a long time. So don't panic. Don't worry about it. The important thing, I think, is that you realize what the possibilities are. So I think by going through this the way we are now, you get a chance to see everything. Obviously, you're not ready to make a three-dimensional plot and rotate it. You're going to need some time to practice and play around with it and figure out how that works. If it makes you feel any better, I'm not ready to make a new three-dimensional plot and rotate it either. Okay? I would have to sit around and play with it. But the important thing is that we realize it's in there. We know the basic structure of MATLAB. We know how to use the help function. We know the syntax. We understand how to put in arrays, how to get the data that we can load. We can use that input command if we want, right? We can always do the fancier stuff when we need to do it. Yeah, the exam, you're wondering what's going to be on the exam? Yeah, we will have an exam. Yeah. Yeah, it'll be, again, I understand why you feel nervous. There will be an exam. I'll just say that I think that the exam will be fair. That what you'll need to do is figure out what's going to come out of some commands. But the commands that you need to figure out should be ones that should be pretty good. Right? So, you might get a couple of questions. What is the size of the output of that command? I think at this point, it's a fair question. Yeah, it's the model of doing this course in about 2 or 3 weeks is not a great model. When Mrs. Ha first asked me about being here to do this, she talked about 2 classes going simultaneously. So I thought this class would also last 6 weeks. If you had 6 weeks, you could spread it out more. You had more time to practice as we go. I didn't know anything about the other class that was going to take up the first 2 or 3 weeks while they were still here and you were taking dynamics. So this class got compressed. I was surprised. I guess you're surprised too. So I think if any class should have gotten compressed, it should have been the other one. Because the other one you can do that much quicker. You don't really have to remember very much from one class to the next. But this one, you really want to remember some of this before you move on to the next lecture. Yeah. So, I'm sympathetic. I agree with you. Yeah, if you think this is going too fast, I have to agree with you. But when I came here, I thought we had 6 weeks. And as it turns out, we really only had a little more than 3 weeks. So. Oh well, we do the best we can. Okay, let's look at 5.8. iPhone 15 can break up the beer. How's that? Okay, reading from formatted files. I think this is the kind of detail that's really, it's fine to know how this works, but it's not something that you probably ever really need to use very much. We can go through this pretty fast. So the function is called fscanf. Remember, load puts an entire file in. If you want to skip text in a file, you can start the line with the percent sign. Okay? And by the way, the percentage sign also works in the command window. So if you want, you could write in the command window, if you want my opinion about doing that, that would be kind of stupid. Because the command window is interactive. So if you write a comment in there, you hit the return button, it's gone. What's the point? But you might want to put comments in your M file. That would be a great idea. If you're going to save the M file and use it over and over again, you should probably put some comments in there to remind yourself what it's doing. To put a comment in that, you start with the percent sign. It's the same thing as putting in // in C++. Okay, now, when you're loading a text file that's full of data, if you want to skip some of the data, at the beginning of the line, you just put one of these in front of the beginning of the line. And when it's reading it, it'll just skip that line and go to the next one. Okay? So it's like turning part of your data file into comments. And you could have real comments in it. So if you remember in C++, if you want to put a data file with XYZ data, it might be nice to have these labels at the top. This would be line 1. And the second line then begins the data. In C++, though, if you try to read this line, you're going to have trouble. Right? So usually we end up having to take that line out, and the data file ends up having only data. In MATLAB, all you have to do is put one of these over there, and that's fine. We'll skip that line. So you can put whatever you want in. You can put another one of these in. So there's a blank in there, right? Or you could put one of these in and put a heavy dash, and it'll look like you're underlining the top of the table. You could put another one of these in, move this down, and put another one in and say, ha 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 ha, I'm skipping you. You do whatever you want in there. As long as it has a percent sign, MATLAB will just ignore it. There is a limitation on the data file. This is too bad, but all the data rows must have the same number of columns. Another excellent reason to use the tab key, because tab always skips over to the same location, and then if you hit it again, it goes to the same next location. So if you use the tab key to move across the row, and each time you tab, then you type in the next piece of data, tab, next piece of data, you'll end up with the same number on every row. You can't have it any other way, because tab will do that for you. Okay, but you don't have to. In between the numbers, you use blanks. You can't put a comma. That's too bad. That doesn't look bad. All right, so here's an example. See, so he put in all this comment at the top. So again, not a bad idea. If you get a data file somewhere, and you're going to be using it over and over again for a long time, but maybe not too often. So it's possible you would kind of forget about it for a while, and then you open it up again. You want to make sure you remember exactly what it is. Write as much as you want at the top. It doesn't matter. MATLAB will skip over that. So you put the points in, and that's what it gets. Any questions about say that one more time? If you want to print text, one thing you can do is just you can just put it. You can say if you're in a command line, right? You can do something like this: A equals. One quotation mark is how you tell MATLAB that you're doing a character. Then you can write whatever you want. Remember, the nice thing is it's not limited to one character. It can be as long as you want, a whole sentence. I love language. quotation on there. All right, that's an assignment statement. If you hit return without a semicolon on the end, what will appear is A equals I love. Okay, now if you want to put it into a write statement, you could have A as the variable that you write. Okay, am I answering the question you're asking? You want to put this in an end file? Yeah, no problem. You can put this, you can put, well, these are the executable commands, right? So you can put these executable commands into the end file. This is a separate data file. You can put that anywhere. This is a file that has a file type txt. It doesn't matter where you store it, as long as you tell MATLAB where you store it. This is the file that reads it in. This could be in the command line, or it could be in an end file. Either way, your choice.
How to create the data out.
Yeah, how to write out. Okay, it depends on where you want it. If you want to write into a file, like something you would store, use a command called print. And I'm sure it's coming up, so let's keep watching. Okay? There's a print. We could go do help print, but let's wait for it. But the command print will enable you to write into a new output file. It's a text file. Okay? But anytime you want to see the output, if you're in the command window or if you're running an in file, don't forget the result of everything you do that does not have a semicolon on the end appears on the screen. So if you want to, let's say you want to actually read all this stuff up here and then have it appear on the screen, right? You can do that. Yeah, we can do that. If you take the percent off of there, then it would try to read that as a number. So that would fail. You have to tell it it's a character variable. But you can read a character variable, that's no problem. Okay, let's look at the next example. Okay. Yeah, let's see, what is this? Yeah, so he's using header. This is, I think, doing exactly what you're asking. Okay, so header is the variable name when we store the text on the first line. All right, so it's this header command. Header equals, this is that fscanf command. And we probably would have to look at help to make sure that I understand all the pieces of the syntax. But the basic idea is this fscanf command enables you to put character variable in. Something with the character in there. That says, I think that says in S, right? It says %S. I think that's what that is. And %S means a string. String is the same as character. String means the same thing. String is what MATLAB calls a character. Okay? So he cleared the workspace. That's the beginning. Always a good idea to clear the data just to make sure that it's starting with a completely blank workspace. So the only thing that comes in is the thing that you're reading, like you read. So clear it first. This is a file ID. Right? So he's telling it the name of the text. Points to .text. You open the file with an fopen function. Associate the file name with an identification variable. That logic is exactly like C++. So the name of the file is right here. But from now on, inside of MATLAB, you have this name, and you can make up whatever name you want. It does not have to be the same as the file. So conceptually, the data file is sitting in a directory somewhere on your computer. It doesn't matter where, as long as you tell MATLAB the right location. And it can have any name you want. When you read it into MATLAB, you can give it a new name if you want. You don't have to, you can give it the same name. Okay, so this is called FID, and it comes from that text. Back up some more to where. Okay, So you open it, give it an identification variable. We use the variable name FID, but you can use any valid variable. Okay? Then it starts reading. FID tells it what the name is inside of MATLAB. And this tells it the format for the read. This is where you can tell it, I want you to read a string variable. Yeah, string is like a character. So it's reading, the name of the variable it's reading is header. That becomes part of the workspace. Header is now a string variable, and it gets the value by reading the beginning of this program. Right? I think 3 is the link. There's 3 sets of characters on the first line. PT pound, space, X, space, Y. Right? Here, here, and here. So this variable header will be an array that's 1 by 3. Header 1 by 1 has 3 characters in it. That's the lingo. PT pound. Header 1, 2 has 1 variable in it, X. Header 1, 3 has 1 variable, Y. Okay? There's another thing you could do. You could tell it to read the whole first line as 1 variable. What would you get? You'd only get the PT pound because when it sees a blank, it means it's done. Okay? So it won't go to the X or the Y. So that's why you have to tell it 3. Then it starts reading in the data one at a time. Point 1, X1, and Y1. Every time it encounters a new assignment statement with this read, it reads whatever number of variables you tell it about here. So this command reads the next one. This command reads the next one after that, which is there. This command reads the next one after that. But you could have put in 3 for this one. In that case, this command would read a 3-character, an array of 3 pieces. And the first would be 1, the second would be 1, the third one would be 0. Okay? So let me back up for just a second. I'll point out, in this data file, because MATLAB treats every blank as a break in between 2 inputs, this data file has 9 inputs. There's 1 here, then there's a break. 1 here, break. 1 here, break. 3, 3. Total of 9. This reading is reading a total of 3, 4, 5, 6, 7, 8, 9. It's reading all 9 of them. But you don't have to read them 3, 1, 1, 1, 1. The first statement could read all 9 if you want. Or the first statement could read 2 or 7. Whatever you want to, however you want to break it up. It's totally up to you. Yeah. If you put 9 in this example, you have a problem because an array needs to be either all string or all numerical. Okay, and the first 3 here are string variables. The last 6 are numerical variables. So this one should have at least 2 different of these read statements. One to do 3 string variables, and another one to do 6 numerical variables. But he didn't do it like that. He did 3 string variables in one line, and then he did 6 numerical variables one at a time. Okay? But he could do 2 string variables, 1 string variable, 4 numerical variables, 1 numerical variable, 1 numerical variable. Right? If there are 9 possibilities, as long as all of his reads add up to 9, it's the same thing. You can also stop short. Right? You could cut this off right here, and it would work just fine. But what it would do is read the first 3 character variables, string variables, and then it would read 1 numerical variable. And then if you stop there, you stop them. You just don't read the other numerical variables. There's no law in MATLAB that says if you load a data file, you're obligated to use all of it. You can just use a small piece of it if you want. Okay? And the idea with this command is to help show you how to get out whatever part of the data file you want, one piece at a time. That's what we're showing you. Okay? Now, when you're reading in data like this, I'll just make a point. If you're missing, you can put in this kind of command inside of an M file or inside of a command window, and you have here a character variable. I'm sorry, string. I gotta start using the word string. A string variable. And this string variable is storing 1, 2, 6, 7, 13, 14, 19, 20, 28. It's storing 28 characters, including 1, 2, 3, 4 that are blank. This is 28 long and it's got 4 blanks in it. Okay, over here, if I'm trying to read these, if I'm reading, the read command stops when it encounters a blank. It thinks it's done reading them. So there's no easy way to read this with all these blanks in here. Okay? This can be as long as I want. But if I'm trying to read it out of a file, the blanks will stop the read statement. And it'll want to put the next word into a new character, a new string word. So this PT pound space X space Y here is 3 string variables because we're reading. But if we put an assignment statement, we can put A equals quote mark PT pound, leave the blank in there, X, leave the blank, Y,